All right, welcome to the second lecture video for chapter 2. I'm going to go into more detail about summary statistics. As a reminder, when you want to understand data, you can do high detail, low efficiency with raw data. You can get moderate detail and moderate efficiency with the visual, which is honestly usually the most useful. Or you can get very high efficiency but very low detail using summary statistics. So here we go with summary statistics. And I'm going to start with the 5-number summary, which is the minimum, first quartile, median, third quartile, and maximum. As I said in the previous video, the minimum is the smallest value. The first quartile is 25% of the way up. The median is the center value. And the third quartile is 75% of the way up. And the maximum is the largest value. We use these 5 numbers to build the box plot, which gives us more of a visual representation. But we can also get those numbers directly, and it's very easy if you just do a summary of your data. It will output the minimum, first quartile, median, third quartile, and maximum. And because the mean is useful, it will also export the mean. So summary of the data. Is done with the code summary of data. Okay. And let me copy this in here. There we go. Okay, so just quick definitions. Minimum is the smallest value. Maximum is the largest value. Median is the central value. So let me give you an example of that. Suppose my data is, and I'm going to use kind of R code just to organize things, right? When I list the data in R, we use C, so I'll do that. 2, 4, 6, 9, 12. The median is the central value, which for this data is 6. Medians can be found for any data set, no matter how big it is. Suppose my data is actually something that looks like 4, 9, 12, 7, 18, 2, 8, 1. Now my data is not in order. So first we want to order the data. So if I order it, I get 1, 2, 4, 7, 9, and 18. And then I find the central value. So the easiest way to do it, I find when you do it by hand, is count in from the outside. So 1 and 18, 2 and 9, 4 and 7. Notice in this case, there are an even number of observations. So the median is halfway between the center two values. So it's going to be equal to 4 plus 7 over 2, which is 5.5. So the median is not always an observation itself. If you have an odd number of observations, it'll be the central value. If you have an even number of observations, it will be halfway between the two central values. The first quartile is the median of the lower half of the data. And the third quartile is the median of the upper half of the data. So let's take this same data here, and I'm going to go ahead and order it. Then the first quartile is the median of the lower half of the data. 1, 2, 4, which is 2. And the third quartile is the median of the upper half of the data, 7, 9, 18, which is 9. Now, R will do all that for you using summary, which is nice, especially when you have 50 observations and you don't want to have to line up 50 observations from smallest to largest. So I recommend that you use R. There is one caveat. R will give you an exact value. Sometimes the Maya Open Math homework wants you to find the smallest value that is larger than the quartile. So for example, let's suppose my data is 2, 4, 6, 9, 12. The first quartile is the median of 2 and 4, because that's the lower half of the data, which would be 3, because that's halfway between them. But my open math may want you to report that the first quartile is an actual observation from the data set. And that's just a warning. If you use R and you put in the first quartile and it says it's wrong, then go back to your data and find whatever number is in your data set and the smallest value in your data set bigger than what R told you, and try that instead. All right, so that's a 5-number summary. Now I'm going to talk about some information that comes from this 5-number summary, which is the range and the interquartile range. So the range is just the maximum minus the minimum value. So let's take that data, 1, 2, 4, 7, 9, 18. The range is 18 minus 1, which is 17. It shows you how spread out your data is. The interquartile range is the third quartile minus the first quartile, which is how spread out the middle half of the data is. Because remember, the third quartile to the first quartile is this box here, so it represents the middle half of the data. The interquartile range is the length of this box. So in our example, we found that the first quartile was 2 and the third quartile is 9, so the interquartile range is 9 minus 2, which is 7. I want to give you a little bit of information. Outliers can change the range a lot. So let's use an example. Again, let's take our data, which has a range from 1 to 18, so the range is 17. Now add one observation, and your new data is going to include the observation 83. That's definitely an outlier. It's far away from the rest of the data. And the new range is now 83 minus 1, which is 82. Big difference in the range. Adding one outlier changed the range by a lot. Outliers don't have a big effect on the interquartile range. So let's take our new data. And I'm going to put big in parentheses. They don't have as big an effect, I should say it that way. Okay, we've changed our data, so our new first quartile is actually going to be halfway between 2, and 4. So our new first quartile is 3, and our new third quartile is going to be halfway between 9 and 18, I believe. Oh, actually, no, our new first quartile is going to be 2. What did I do? Let me make sure. I got to slow myself down here. 1, 83, 2, 18, 4, 9, 7 is our middle. Okay, so actually our first quartile doesn't even change. It's still 2. But our third quartile changes. Our third quartile is now 18. So the new interquartile range is 18 minus 2, which is 16. And so it certainly did change, but it didn't change as much as our range changed. And if we had a bigger data set, like if we had 100 observations all in this range, and then we added 83, our new range would get really big, but our interquartile range wouldn't change at all. All right, so checking back in, we're talking about summary statistics for understanding data. I've talked about the 5-number summary. Now I'm going to talk about the other way to understand center and spread, which is using the mean and the median, or sorry, using the mean and the variance. So the median and the interquartile range are a way of understanding the center and spread of a data set. The median tells you where the center of the data set is. The interquartile range tells you how spread out the data is, and it's robust to outliers. Another way to explore the center and spread of data is the mean and the median. Sorry, the mean and the standard deviation. So the mean, also known as the arithmetic mean, is found by adding all the observations, then dividing by the number of observations. Probably you've done this at some point. Mean is often called the average, and statisticians, for whatever reason, at some point decided to call it the mean, which of course is confusing because mean also means definition. But it's something to get used to. All right, the mean is also often called the average. So let me use an example. Here's our data. 1, 2, 4, 7, 9, and 18. The mean is 1 plus 2 plus 4 plus 7 plus 9 plus 18 divided by, and there are 6 observations. So the mean is 6.833. The arithmetic center of the data, right, the balance point of the data, the mean is like the balance point of the data. If you had to balance your data distribution on a single point, you want that point to be right at 6.833, and it'll be balanced. The standard deviation is a way to explore the spread of the data. Calculating the standard deviation is laborious. It's labor intensive. You would not want to do it with a large data set pretty much ever. You are going to do it one time on your homework, kind of by hand, and every other time I'm going to encourage you to use R. And so I'll show you how to do that in R in a minute. But the steps are as follows. Here we go. Steps for standard deviation. Calculate the mean of the data. Find the difference between each observation and the mean. Square all of those differences. Add up all the squared differences. Divide by the number of observations less 1. And then take the square root. So let me give you an example. This mostly is just for your notes. I'll show you an example. You'll do this once on your homework by hand, and then you'll always use, well, I hope you'll always use R after that. Okay. So here's our example. Sorry. My data is 1, 2, and 6. And I want to know a number that describes how that data is spread. So I'm going to calculate the standard deviation. First step is calculate the mean. 1 plus 2 plus 6, all divided by 3 equals 3. So the mean is 3. Step 2, find out how far each observation is from the mean by subtracting. So the first observation minus the mean, 1 minus 3 is negative 2. 2 minus 3, 2 minus 3 is negative 1. 6 minus 3 is 3. Third step, we want all these distances to be positive. The easiest way to make all numbers positive is simply to square them. So we're going to square the minus 2. Minus 2 squared is 4. Minus 1 squared is 1. And 3 squared is 9. Step 4, we're going to add up all those square distances. 4 plus 1 plus 9 is 14. We're going to adjust that single number by dividing by the number of observations. So if you have a really big data set, you're going to get a really big sum of square distances. So you divide by your number of observations less 1, and we get 7. Mean, put the difference, square up those differences. This is step 5. And then, oops. And then step 6, take the square root of the result. Square root of 7 equals about 2.64. So the standard deviation of the data set 126 is 2.64. In the next video, I'm going to talk more about why we care about the standard deviation and what it actually means. This video is just showing you how to calculate it. There's one other summary statistic that I want to show you. This is also a measure of the spread of data. It's called the variance. The variance is simply the square of the standard deviation. So in our example, the standard deviation was 2.64. The variance is 2.64 squared, which is 7. And the variance is simply another measure of the spread of the data. So in R, you can do all of these very quickly and easily. Let me just show you the code. We're going to use our 50 observation data set. And we find the mean of the data, 101.78. Now let me bring up the histogram. This one here. The mean of the data, remember, is roughly the balance point if you were to balance it, and it's showing us the mean is right about here, just to the right of the 100 mark. The median of the data is 101.5, so the central value right, the middle of our data set is probably two numbers. It's probably 101 and 102, or maybe it's 100 and 103, something like that. If you want to find the range, I find it easier to find the range, you can just take the max of the data minus the min of the data. And to find the interquartile range, I find it easiest to first do the summary, which tells you the third quartile and the first quartile, and then just do the subtraction by hand. And we get an interquartile range of 13.8. To find the standard deviation, you do SD. So this data has a standard deviation of 9. And the variance, you can do VAR, variance of 88. Now I forgot there's one more statistic I have to tell you about, which is called the mode, which I consider to be a mostly useless measure of center, called the mode. The mode is just the most common observation. In numerical data, especially continuous data, the mode doesn't have much meaning. So here's a short example. Well, let me use, for example, the 1, 2, 4, 7, 9, 18. The mode here doesn't really exist because each observation appears once. A mode would show up if you had something like 1, 2, 3, 3, 4, 5. The mode is 3. It's the most common observation. In this case, it's central, right? The 3 seems to be roughly between the 1, 2, 3, 4, and 5. But a mode might not be central at all. In this case, where the data is 1, 2, 3, 4, 9, 9, the mode is 9, which is not central. So I don't think that the mode is very useful, but it is something that you need to know about. And if you want to find the mode using R, it's easiest to table your data, which will show you the number of observations or the number of observations for each value. And then you can scan and find that 97 shows up 4 times, which is more than any other value. And so the mode here would be 97. Let me copy this into there we go. All right, that closes up this video. And in the last video today, I'll talk about or the last video for chapter 2, I'll talk about why we look for the standard deviation and what we use it for.